Hello, everybody. Welcome to your lecture in Deserts and Wind for Physical Geology. We're going to be going through giving you a little bit of background on how wind works and big convective cells of wind works in the Earth, and also talking about some of the world's deserts. So we're going to be going over, and this is actually a pretty short one, so you'll probably appreciate that fact. So I have your lecture assignment up here. Let me bring it up. And we're going to be talking first off, like what is a desert? And I'm sure you all have some kind of intuitive ideas what a desert is. A very dry place. Atacama Desert is the driest place on Earth. It's in Chile. It's actually on the eastern side of the Andes Mountains in Chile. So we're going to talk a little bit about why deserts often form next to mountains. So desert, what is a desert? First of all, you got to know the definition of desert. That's question number one, right? Is what is a desert? What's the key criterion? And the key criterion is, of course, rainfall. So deserts are any place that have less than 10 inches, receive less than 10 inches of rain per year. Here in Corpus Christi, we are we get like on average around 33 inches. So we're not a desert at all. I know sometimes it seems so dry here. Sometimes I think, gosh, are we semi-arid or something? But actually, we're not at all. We get a fair amount of rain. We actually get about average rainfall for the United States is 38 inches per year. We get 33 here in Corpus Christi. So it's we're not arid at all. So some places are much drier. And, we have some deserts here in the United States, right? You'll see a lot of the United States, especially the western United States, is covered with desert. And a lot of Mexico is covered with desert as well. So we're going to talk about some of these different kinds of deserts. The main two kinds of deserts, there are a lot of different kinds of deserts, but the main two kinds of deserts that I wanted to talk about today are kind of rain shadow deserts and what are called STH deserts. And STH deserts are called subtropical high deserts. Now you'll notice that the second question on your lecture assignment asks you, look at a map of global distribution of deserts. So you're looking at it right now. Okay, it's global distribution of deserts. What line of latitude do most deserts form? Or I shouldn't say most, but many deserts form. So notice that up here, this is the Arctic. Not many deserts in the Arctic. Now, keep in mind, there can be cold deserts. Deserts don't mean hot. They mean low moisture, okay? So we do have cold deserts. I'll talk about those later. So you notice Arctic, no deserts there, right? If you look at the equator, not really too many deserts. You get some getting kind of close to the equator there in Africa, like the southern part of the Sahara. But for the most part, no deserts really along the equator. I guess you have a few that are getting close there in South America. Those are actually steppes, though, so it's a little bit deserts. So deserts are this not the brown color, but the actual light yellow color. Let's look at the tropics. Oh, desert there. It's the Chihuahua Desert and Sonora Deserts in North America. Oh, desert right here. That's the Saharan Desert, right? The Arabian Peninsula Desert. There's another desert there, right? We go to the other tropic down here. What do we see? Deserts. The Kalahari Desert, and the Namibian Desert, the Simpson Desert in Australia. So, wow, a lot of deserts along the tropics. These are what are called STH deserts. They are subtropical high deserts. So they're deserts that form around the subtropics, so close to the tropics. So those are a very, very important thing for understanding deserts. We get a lot of deserts forming around the tropics. Why? And to explain why that is, we're going to have to talk about wind today. So that's why today it's kind of like deserts and wind. It seems like kind of a weird combination, but they go hand in hand, actually. Okay, so why do most deserts form in the subtropics? Let's talk about that, because you can see there's the subtropic lines. We get the Chihuahua and Sonoran deserts in North America, Sahara Desert, the deserts around the Arabian Peninsula, the Simpson Desert. So many deserts are forming around the tropics. So why is that? So it has to do with the global distribution The global distribution of deserts has to do with the global wind cycles. Okay, so this is a really complicated GIF that's playing right now for you, but it's showing you what are called the global circulation of wind on Earth. Okay, so I want you to notice that air rises here at the equator, and it rises because it's hot. And as it rises, it cools down. I'll talk about why it cools down later. And then it spreads either to the north or to the south, and it starts coming down around the tropic lines. And when air descends, it actually heats up. It gets hotter. And that air that comes down at the tropic lines, that's called the air that comes down at the tropic lines, that's very hot, dry air. So this cell that's convecting right here, you see this cell that's convecting? That's called the Hadley cell. This one that's convecting right here is also the Hadley cell. So you see there's a Hadley cell in the north and the south hemisphere. Okay. Now you'll notice that there's another cell that is circulating here. Okay, that's called the Ferrel cell. There's another one down here, that's another Ferrel cell. And notice how it's going in the opposite direction of the Hadley cells. Do you see that? So see how the Hadley cells look like they're going like clockwise here, right? You see that, whereas the Ferrel cell is going counterclockwise. There's a third cell up here called the polar cell as well. But the most powerful cell and the biggest one you can see is the Hadley cell, and that's the one that's controlling the deserts and why they're forming at those subtropical lines and creates the subtropical high. Okay. Now when this, let me erase some of the ink on this so you can see this better. When this air comes down around the tropics from the Hadley cell and the Ferrel cells converging, it's coming down, like I said, it's very hot and dry. I'll explain why that is later. But it comes down hot and dry, and also air blowing down on a surface, right? Air is coming down, it's converging down onto the surface. That creates a high pressure, okay, high atmospheric pressure. So that's why we call this area, this line right here, the subtropical high, okay, and the subtropical high. So these are subtropical highs that come down right around the tropic lines. They actually move a little bit seasonally, but they come right around the tropic lines, Tropic of Cancer, Tropic of Capricorn, and they create a line of high pressure and also high heat and high, or I should say low humidity. Okay, so that's why we have deserts forming there. Okay, so here's just another picture of the Hadley cell. Comes up, right, air is rising at the equator. It rises at the equator just because the equator receives a lot of solar radiation. Okay, and then it either moves to the north or south, and then it's going to come down at around the tropic lines, okay, around 30 degrees north, 30 degrees south, 30 degrees north. That's why we call it subtropical. It doesn't come down strictly at the tropics, because remember the tropics are 23.5 degrees north-south, so it's coming down more around like the 30, so that's more the subtropics. That's why we call it subtropical. So hot air at the equator rises because of the high temperatures, the amount of solar radiation the equator receives, and rises at the equator is going to come down around the subtropical lines. Now remember that as you go up into the atmosphere, you increase in elevation and altitude, pressure drops. So I'm asking you, number 4, how does air pressure change as you go up in elevation and down in elevation? As you go up in elevation, the pressure drops. As you go down in elevation, the pressure increases. Okay, so you see that this is showing pressure. Air pressure is a function of altitude, and you can see that as we go from sea level and we go up, air pressure is dropping. Okay. Now, this is something that you need to understand about gases. It's kind of a weird thing, but it's something that's really important for understanding why deserts form at the subtropical highs. Okay, maybe if you ever played with one of these things, have you ever seen these things? You can buy this at HEB. It's actually my computer actually kind of needs it. Whoa, Kind of needs a dusting. It's really dirty in here. Yeah, sorry, I got all the crumbs from lunch. But I noticed that as I spray this stuff, this compressed air, it kind of used for dusting off your electronics. I notice as I use it, it's getting really cold. So the bottle itself is getting really cold. And some of you might know that you can actually look at like YouTube and things like that, and people try to like freeze locks off with this stuff. So it can get really cold. Now here's a question for you. When I was a kid, I used to grab my sister's hairspray. It was the 80s. I'm sorry. I used to grab my sister's hairspray bottle after she'd spray like a tremendous amount onto her hair. And then I'd say, oh, it's cold. And I just thought as a kid that it's cold because the hairspray is cold. And that's not true at all. The stuff in here in this can is not cold. It's the depressurization of the gas that changes the temperature. It gets cold because it depressurizes. And that's just how gases work. I could go into all the thermodynamics of why that is, but probably I assume you probably don't want to hear that. So as gas expands, though, the important thing is to note that it cools down. And vice versa is true as well. So, as we go up in elevation, the pressure drops. So as we go up in elevation, pressure, actually this is going down in elevation. As we go up in elevation, the pressure goes down. Okay? And what's going to happen to the gas as you go up in elevation? It's going to cool down. Okay, so the air is going to cool down as it rises at the equator as part of the Hadley cell. Okay, so does air expand or compress with greater pressure? Think about that. That's number 5. Does air expand or compress with greater pressure, right? Well, you might know that air is going to expand, right? So as you release pressure, the air is going to expand. And how does the temperature of the air change as it either contracts or is compressed, or if it expands? So if the air expands and is released, it cools down. Vice versa is also true. If you compress the air, it heats up. I know some students who work in like industrial settings, and they have like these super high pressure air pumps and things like that. And they'll say, Dr. you were mentioning this, and I noticed that those air pumps get really hot. And you might notice this too. I don't know if any of you like to like bicycle ride or anything like that, and you might notice that your bike pump, if you ever use a hand pump like this, I use one of those to pump up my tires. I always have flat tires for some reason. I don't know what I'm doing wrong. If any of you know why my bicycle tires always go flat, tell me. But anyway, I'm always pumping up my tires, and I notice those hand pumps get really hot. They get like over 100 degrees, and they get so hot it feels hot to my hand. I'm pumping really hard. So what's happening is because I'm compressing the air, so it's getting hot. So air gets hot, it heats up as it contracts, as it gets compressed, and as the pressure increases. Okay, so think about this. We start off at a high altitude, okay? The air starts sinking as part of the Hadley cell. It starts sinking there at the tropic lines, the subtropical lines. And what's going to happen to the pressure? It's going to increase. As we sink down, it's going to increase. The air is going to contract, compress, and the temperature is going to go up. So that means the temperature goes up. That's what creates the hot, dry air at the equator. Or I'm sorry, at the subtropic lines. Now, why is it dry? It's dry because when that air first rose at the equator, it cooled down and it precipitated all its moisture out. So that's why there's a lot of precipitation. And the world's rainforests, where are the world's rainforests? They're right on the equator. There's a lot of rain at the equator because the air rises, it expands, it cools, it precipitates. That bone-dry air then goes up and comes down at the subtropical lines, and it gets heated up by this kind of pressure heating. And it's called, by the way, it has a fancy word. It's called adiabatic heating. But it comes down. You don't need to know adiabatic, but just FYI, it's called adiabatic heating. So then it comes down at the tropical lines right here. Okay, it comes down at the tropic lines. It's bone dry. It's hot. And that's what creates deserts at the subtropical lines, okay? So now you understand, or I hope you understand at least, why we have those kinds of deserts. at subtropic lines. Okay, so what is one example of real life subtropical high deserts? So many you could mention here. Here's the subtropic lines. Okay, the Chihuahua, the Sonora, the Sahara, the Sind. I guess this one in the Arabian Peninsula is called the Rub al Khali. I didn't even know that. But the Simpson Desert in Australia, the Kalahari and the Namibian Desert in Africa, South Africa. Okay, the Atacama Desert is also Atacama Desert is more of a rain shadow desert. We'll talk about that later. All right, so you're supposed to, number 9, supposed to draw a picture of the Hadley cells. Okay, so just to kind of show how that's going to go here, this is the equator. So right, you're going to be showing the air rising and moving there to the right, to the left, to the north, to the south. So I kind of get it started for you, but that's what I want. So I want you to show where it descends and also where the air is. So where the air is going to be coming down. I guess I showed where it rose, but okay. So anyway, number 10, I said, why do STH deserts form? What causes there to be subtropical high deserts? Please explain there. I just got done explaining all that stuff, but please explain there why the air is hot and why it's dry. Why the air is hot and why it's dry at those areas. All right, so moving on, I want to talk about rain shadow deserts. So the Atacama Desert is the is the driest place on Earth. It's a very strong rain shadow desert. So what is a rain shadow desert? Let's talk about that. So this is called the rain shadow effect. Remember that when air rises, the pressure drops. When the pressure drops, the gas cools. The air cools. Okay? Now when air cools down, it can't hold as much moisture as it can when it's hot. So it starts to precipitate. So that's why, for example, whenever there's a cold front comes in, it usually rains. Because that cold air comes and it cools the air down, and it causes all of the moisture to precipitate out, right? Because cold air can't hold as much water as hot air. So the hot air rises when it meets a mountain, right? So let's say the hot air is moving along, it's hot, moist air, it meets a mountain, it's going to start rising to go over the mountain, and it's going to cause there to be lots of rain on one side of the mountain. So one side of the mountain is often going to be very lush and green. On the other hand, when you go on the other side of the mountain, now that air is bone dry. It's lost all of its moisture through precipitation, and it starts sinking on the other side. And as it sinks, it heats up. And also another thing, this gets into more weather. You don't need to know this per se, but it's just more explanation. When precipitation occurs, when condensation occurs, it actually releases heat. It's true. When water condenses, it actually is releasing heat. So after the precipitation event occurred, the air heated up even more. And now that it's going to sink onto the other side of the mountain, it's heated up even more through adiabatic pressurization heating. Okay? So that creates hot, dry air descending onto the other side of the mountain. So you'll actually often see this where one side of the mountain is very lush and the other side of the mountain is very dry. Okay? So I can actually give you some examples of that in the next picture. So here's a little GIF video showing how this actually works. Okay, just animation of how this works. So the water vapor condenses and forms clouds as it rises up over one side of the mountain. Then as it descends, it warms up, it compresses, and it creates a hot, arid environment on the other side of the mountain. So that's what's called a rain shadow desert. The windward side, that means the direction from which the wind is coming, is the lush side, and the leeward side is the dry side. Okay, so leeward means the direction towards which the wind is blowing. The windward side means the direction from which the wind is coming. Okay, so here's yet another picture just showing the arrows are trying to show the temperature of the air as it rises above the mountain and passes on to the other side. Really famous rain shadow desert is the hottest place on Earth, Death Valley. And it should kind of surprise you that Death Valley, the hottest place on Earth, it's in California, and it's also in a place that is, it's not on the equator. You would maybe naturally assume it would be on the equator where we get the most solar radiation, and it's not. It's at these subtropical high areas. It actually has a latitude, I think, of around 34 degrees or 37 degrees north. Okay, it's a rain shadow desert. Okay, so rain shadow deserts. There's some more. Like I said, there's rain shadow deserts in California. Rain shadow deserts in around the Rocky Mountains, right? And so around the Midwest here, not Midwest, I shouldn't say Midwest, but around the Rocky Mountain areas, there's rain shadow deserts. Anywhere where there's mountains, you often get rain shadow deserts. Okay. There's a beautiful picture of the Atacama Desert. Okay, that's in Chile. It's a rain shadow desert. Lots of rain shadow deserts, like I said, around the Rockies and around the Great Basin areas here in the west of our country. Lots of rain shadow deserts because there's lots of mountains there. Okay, here's Death Valley. It's a very famous rain shadow desert. I know it has a horrible name, but it's actually really a beautiful place to visit. If you ever get a chance to go to Death Valley, I would take it. Look at this. This is not photoshopped or anything. This is called the Artist's Palette in Death Valley, and it has all these different colors of rocks. It's really cool. I do not know. I'm interested now what causes that like greenish blue turquoise color. That is really striking. I've seen this before, but I never actually thought about what causes that greenish color. Mosaic Canyon is also really neat. It's a breccia. Remember we studied breccia, right? It's a canyon that is formed from breccia, and it's real like smooth and polished breccia. It's a really, really neat place. Also has the Mesquite Flat sand dunes there, really beautiful sand dunes, and so many other places. There are actually a ton of really interesting places in Death Valley. There's the Devil's Golf Course, which is all salt flats, so you can literally pick up the ground and take a bite of it if you wanted to. It's salt. It's all salt, so it's pretty interesting. The Colorado Plateau area, like Monument Valley, like all these like classic, like you see in like classic Western movies. A lot of those are rain shadow deserts. Okay, high elevations, hot summers, cold winters. So anyway, that's how rain shadow deserts work. I'm not going to talk too much here about hot deserts and cold deserts, but I did want to just point out that there are actually, we all know that there are hot deserts, right? But there are actually cold deserts as well. So this is Katpana Desert in Pakistan, and as you can see, it looks like a desert, right? There's not much vegetation. There's sand dunes, but there's also snow because it's a very cold place because it's at a high elevation. So and some of them are at high latitudes as well. So not all deserts are hot. Remember, the key criterion for deserts is, are they cold or are they dry, right? 10 inches or less of annual rainfall. That's what makes a desert. It has nothing to do with temperature, actually. So some deserts are cold. Okay, so sand dunes. This is a little animation about sand dunes. It's like drone footage of sand dunes. So you know that sand dunes are often formed in deserts because water is sparse. Wind is a very dominant agent of erosion and deposition and weathering, okay, through abrasion. So sand dunes often form. One thing that's really cool about sand dunes is that they can actually tell you might remember this from sedimentary structures. We can actually look at cross bedding in the rocks and figure out what the direction of the wind was at the time. So one thing you have to understand about sand dunes is that sand dunes are not stationary. They do not just sit there. They migrate. So this is showing how sand dunes migrate, this little animation. And it's actually showing you how that cross bedding forms. So you notice how you got these slanty lines here, like all these slanty lines. Those slanty lines are from when the wind causes the sand on the tip to avalanche over the top of the sand dune and collapse on the leeward side. Okay, so those slanty lines dip towards the leeward side, and they're kind of slanting towards the windward side. Okay, so you can see the wind is coming. So that's how you can look at a rock, the cross bedding in a rock, and figure out the direction of the prevailing wind at the time the rock formed. Okay, so this is a 2-year time lapse from the Sahara Desert, and notice it's really, really cool. You know, they're collapsing, they're moving, they're migrating. The ripple marks are forming and then recollapsing. So you can see they're not static at all; they are moving. So that's why now you know things like this. I always think this is such a great class to take, this in like the geology classes, because hopefully if you ever start buying real estate, you're going to be more judicious now about what you buy. So like here's a guy who invested in a nice little beach cottage, but what happened? Well, he didn't remember. I shouldn't say he or she didn't know or didn't take physical geology and didn't know that sand dunes move around. They move around a lot. So and it can move around over hundreds of years. So your beach cottage might be standing there for 50 years, but in 10 or 20 or 30 years more, it might be enveloped by a sand dune. So be really careful about investing in real estate next to sand dunes, because they move, and then there's not very much that you can do to stop it. So there's a lot of different kinds of sand dunes. I'm not going to go into all the different forms of them, but some of them have very interesting shapes. This is the White Sands National Monument. I did want to talk about some different things that happen in deserts. I know that your last question there is about different kind of like geographical features of a desert, and we'll get to that in a minute. A lot of times deserts have things called desert pavement, where all the sand and silt gets blown out of the sediment, and you get left with just this deflation of gravel. So that's why you go around. It looks like almost like somebody laid down cobblestones in the desert, but it's just because all the silt and sand got blown off, and all that's left is cobbles. There's also these things called ventifacts. I know that you're looking at it and you're like, oh, that looks kind of boring. But if you ever got to hold a ventifact, you'd be like, oh, this is really cool. It's so smooth. So there are these rocks that get blown and abraded by the basically sandblasted, right, in the desert. And they become like so nice and smooth. And they often get this kind of like triangular shape. I hope you can kind of see this triangular prismatic shape there. So ventifacts are really neat. There's some more pictures of ventifacts. So if you ever get to go to a desert, look for ventifacts. They feel really nice. Alluvial fans also very commonly form in deserts. That's where rivers out of the mountains that, of course, they're ephemeral streams, right? They're not flowing year-round. But when there is a sparse rainfall, they fill up these canyons with water, and it will take all the sediment out of the canyon, and it'll dump it into a basin and form what's called an alluvial fan. So this fan shape of sediment that's at the mouth of this mountain stream in a desert, it's called an alluvial fan. Another thing that you should know are called wadis. I know that my veteran students who have maybe been in the Middle East, they know about wadis. So a wadi is a dry stream bed, and it drains out into a playa. So what is a playa? This area right out here, this is the playa. Okay, a playa is like a flat basin that's or a flat valley that is bordered by mountains. And so what happens is when you do get a rainfall, the water flows out of the mountains into the playa, and it often evaporates. So often in playas you get salt buildup and things like that. So you get these like salt flats. So a wadi is a stream bed that's flowing out of the mountains. Usually they're very important because usually in a desert environment it's the best place to look for water. So you can dig down into the wadi, and that's the best place to dig like a well to find water. And you can in fact see that there's some vegetation in the wadi, so that shows you that there's some water there underground. So like I said, when the water flows out of the wadi, it goes into the playa, which is this flat basin area. And the playas contain these salt-rich waters that then evaporate and they leave salt flats. So this is all the stuff that you're looking at. Like I think this is the Devil's Golf Course in Death Valley, but there's also the Bonneville Salt Flats that are around Salt Lake City, and they're just these vast playas that just flat, and it's just salt. As far as the eye can see, it's salt. It's really interesting. They often get mud cracks and things like that, and when they dry up, and they leave salt deposits, and it's a source of a natural source of salt. Okay, so looking at some more things you might want to know for your number 14, labeling some of these features here. You probably heard of these large flat-topped highlands, part of desert environments that are called plateaus. When the plateaus are smaller, we call them mesas. So probably you've been driving. I know that actually not too far away. If you drive to San Antonio, you'll actually see some mesas. About like halfway through your journey, you'll start to see like mesas. There are mesas over there. They're flat-topped, little smaller than a plateau, but they're flat-topped. When it's really little, we call it a butte. Okay, so the name of that is a butte. The slopes of sediment that surround a butte are called the pediment. Okay, so those are all things that you see in your number 14. You have a butte, you have a mesa, and you also have a plateau in your number 14 exercise. The sediment, again, that surrounds the butte that's been eroded off is called the pediment. Okay. There's also these little things called Inselbergs, which are basically old volcanic features. Sometimes they're like necks of volcanoes and the actual volcanic edifice has been eroded away, but what's left is like the volcanic neck, or maybe they're like a underground magma body, or maybe they were just some kind of igneous feature. And so they're interesting because they are associated not with tectonics but with volcanism. They're often just isolated by themselves, these little pointy hills that are just poking out of the desert in random places. So those are called Inselbergs, often the remains of igneous features, necks of volcanoes or something like that. And that's it. I think I got everything I'm looking to make sure that I got everything that's on your picture. And yeah, I think I talked about everything that you see on your picture. So number 14, I did talk about everything. Okay, so wadis, playas, alluvial fans, mesas, buttes, plateaus, Inselbergs, pediments. So I think I got everything. Finished in only 32 minutes. So you have a good week. Let me know if you need any help with your lecture assignments, and hope to see you at the next class meeting if you like to attend those. So you have a good week, good weekend. Talk to you next time.